Hello all, this is another question from GATE Metallurgy 2021. The question says, in a material, a shear stress of 100 MPa is required to bow a dislocation line between precipitates with a spacing of 0.2 micrometer. If a spacing between the precipitates is increased to 0.5 micrometer, the shear stress to bow the dislocation would be how much? So it is a very easy question. So how to go about? We know that if there is any precipitate, let's say something like this, we have two precipitates, and if we have a dislocation line, okay, traveling in this particular direction, what happens? These precipitates will act as obstacles, and if the precipitates are coarser enough, the dislocation will try to bow or form a loop around this particular precipitates. So how it will look like is something like this. So it will try to form a loop something like this, okay? And slowly the loop gets expand, and we know that dislocations will be multiplied, which is explained by the Frank Red source, okay? But for this particular question, if you see, the dislocation line previously is a straight line, and because of these obstacles, it has to bow around. That means it has to bend around these precipitates. And if the distance between the two precipitates is L, then the shear stress required tau is given as GB by L. Okay, so what is tau? Tau is nothing but the shear stress required for bending a dislocation or bowing a dislocation. G is nothing but the shear modulus of the material. B is the Burgers vector, or I can say the magnitude of the Burgers vector. Okay, and what is L? As I told you, L is nothing but the distance between the obstacles. In this case, I can write precipitates. Okay, so now what they are telling is initially L, the distance between them is 0.2 micrometer, and we can see from the relation also that given for a given material and for a given dislocation, that means G and B are constant. I can say tau is inversely proportional to the length or the distance between the precipitates. That means if the distance is increasing, what happens? The shear stress, amount of shear stress required will be decreasing, right? So from here I can say two cases. I can say tau 1 by tau 2, this would be equal to L2 by L1. Correct? This is the inverse relation. So initially they told that tau is 100 MPa. So 100 divided by tau 2 is equal to 100 MPa is when the spacing is 0.2 micrometer, and now this is 0.5 micrometer. So from here I can say the second case tau 2 would be how much? 2 by 5 times 100, right? So this goes 20 times, therefore the shear stress required is 40 MPa. So that's how this will be happening, right? So the length or the distance between the precipitates is increased, hence the shear stress required has been decreased. So therefore the answer is 40. So I hope this concept is clear. Thank you.